Hello everyone, welcome back to MAT1033. So in this video, we will be talking about radical principle and radical function. But before we started the principle, let's do a quick recall on exponent and power number. As you know, if we multiply 2 by 2, I can write it as 2 raised to the second power, which is to give you 4. Now, the reverse process is nothing but you can ask a question that what number multiplied each other 2 times to get 4, which is number 2, right? The same thing over here. If you know 4 times 4 times 4 is actually 4 to the third, is 64. Now, the reverse process of finding the number 4 is nothing but questioning yourself what number multiplying 3 times by itself to give you 64, which is number 4, right? Which is number 4. So you can do the same thing as over here. I can do this. I can, for example, 5 times 5 times 5, which is 5 to the third power, give you what? 125. What number multiply 3 times by each other give you 125, which is 5. Okay. The process of finding that number, we call that radical. All right. So in this video today, I'm going to talk about radical principle. It means we using this principle to find the number. To find the number over here multiplied 3 times to get 125. And on the second part, we're going to talk about radical function. Okay, so let's get started. So this radical principle, I have to be honest with you is that I already made a video, but when I'm writing and giving a lecture, but actually I lost the video. So I have the file, but there's no sound, so I have to redo it. Now, the radical notation is this. This is the index, and this is called the root. Okay, it's called the root, or some we call that the radical or the root. So this is the root. Okay, and whatever inside we call the radical. So the index, it must be positive integer. Okay, we don't have negative integers. Okay, if the index n over here is negative, it doesn't make sense. So we don't have it. Okay, and the index could be even or odd. If index is even, for example, n is even for like 2, 4, and 6. Okay, 2, 4, and 6. For example, if n equal 2, if n equal 2, we call the square root. If n equal 4, we call the fourth root. If n equal 6, we call the sixth root. Okay. And if n equal 2, I can write second radical of a square. I can write it as second radical of a square without the index. Okay. And if we have square root of a square, which is always give you absolute of a. Okay. So in general, if n is even, n root of a raised to the n is always give you absolute of a. Okay, always give you absolute of a. Now, if n is odd, for example, n equals 3, 5, 7, and n root of a to the n will give you a. So you see the difference. You see the difference between n is odd and n is even. One give you absolute, the other one does not have absolute. Okay. For example, if I have a square root of -7 square, which is give you absolute of whatever inside of here, because the index and exponent is even, and absolute of -7 is 7. Same thing over here. The index is the same. So which is give you absolute of -3, which is give you 3. Okay. Now, if you write the answer as -3, would be wrong, because most of the time some student put like this: a 6 root of -3 raised to the 6 is -3. That would be wrong. Okay, it's wrong. It's terribly wrong. It give you +3, not -3. Okay, but if n is odd, so for example, in this case, is n is 5, and the exponent is also 5, and the a over here is -4, so it turned out to be a itself, which is -4. Okay, no absolute. Okay, and the same thing over here turned out to be absolute of -9. However, there's another negative over here, so absolute of -9 is 9, but you still have the minus, so the answer is -9. Okay, and for this one, the radican now is not a number anymore, but the radican is a value, is a variable here. So I changed a little bit. So this is 12 degree, 12 exponent over here. I can write this as a to the 4 raised to the 3rd power, right? Because 4 times 3 is 12, and you see the exponent here, and the index here is the same, right? Exponent and index is the same. See here, I'm going to use the purple. The index here and the exponent here is the same, and it's odd, so it turned out to be a to the 4. But for this one, the index is even, and I can write something with something raised to the 4th. So this is 4 and 4. So the index and the exponent is even, so that can give you absolute of x to the 3rd. Okay. The same thing for this, -694, I can write as -4 raised to the 3rd, and because this is r, so it turned out to be itself, which is -4 only. Now for this one, 1296, if I use the prime factor 3, I can write it as 2 to the 4 and 3 to the 4. 2 to the 4 times 3 to the 4, I can write it as 6 to the 4. Remember one of the formula? The formula is if I have a to the n times b to the n, which is give you a times b to the n. Okay, that formula over here. So this is give you a times b to the n, be 2 times 3 raised to the 4. And you see the exponent here, and the index over here is even. So which is give you absolute of 6, is give you 6. Okay. Alright. However, for this one, because this is a 4th root, and this is negative number, and that's why it's undefined. We cannot do it. Okay, because it's negative number. If it is 3rd root, then maybe we do it, but this is 4th root, we cannot do it. Okay, the 3rd root it works. Okay, because remember we will have -2 times -2 times -2. The 3rd root of -8. Okay, 3rd root of -8. 3rd root of -8 is still give you -2, because -8 is -2 times -2 times -2. So 3rd root of -8 is -2. But 4th root, even root, you cannot take negative. Okay, but for the odd root, you still can take negative. Okay, because think about it, you can do it. You can write like this. This is nothing but this, right? Right, and of course it's turned out to be this. Okay, it turned out to be this. Is that according to the principle? Okay, according to the principle. Now for this one, what if the inside the radical is a fraction? I can write 1/64 is 2 to the 2 1/2 raised to the second. Of course, it gives you absolute. Absolute of half is still a half, and we just give you negative. Okay, and the same thing over here. I can write this as sec root. Sec root. So over here the index and the exponent the same. So we just give you absolute of x to the 5th power. And remember, okay, it's always give you absolute if the index is even. Okay, if the index is odd and exponent is also odd, it will give you itself no absolute. So that's the difference between two different principles right here. Okay, the root, the end root, even root, and the odd root. Okay. All right. So now on the second part of the lecture, we're going to talk about radical function. But before we talk about radical function, let's see what is the radical expression. Radical expression is an expression containing radicals. So it means it can contain one radical, for example, like this, or like this, and it could be any root. It could be the n could be square root. It could be n could be 3. It could contain 2 variables. It could contain more than 2 radicals. Okay, something like this, or it might contain different radical. For example, for example, I have something I have a 4th root of x to the 4 y square and plus to the 3rd root of x plus 1. It could be like this. Okay, it's just complicated, but it could be a different radical. Could be more than one radical, but could be different index. Okay, now if I go ahead and put one of the algebraic radical expression and set it equal to fx. So if I set equal to fx, we know that fx is a function notation, and we can obtain the radical function. Okay, so in this course, we just focus on 2 different radical functions, which is square root function and the cube root function. And square root function is nothing but n equal 2. And if n equal 2, we have fx equal to square root of x. So this is called square root function. And the sketch for square root function look like this. Okay, it look like this. Okay, and if it look like this, then you see that the domain and range could be from 0 to infinity. Okay, and this you have to include 0 also because over here, think about it, you can take a square root of 0. So at 0 still work. Okay, so that's why we have to use the bracket. So remember this: if the sketch of all root function is always similar to the shape above, it means that if n equal 4, 6, 10, 8, the sketch is always look like this. And if n equal 3, a typical example of odd root function, I'm sorry, not even. Odd root function will be cube root function, cube root of x, and the sketch of cube root of x is always go like this. Okay, and if it go like this, you see the domain and range is always go from negative infinity to positive. And similar to the square root function, for the odd root function, okay, for all odd root function, the sketches always look like this. I mean that the domain and range of all odd root function will be like this all the time. Okay. However, for the even root function, the shape is always like this, but the domain might be different. Okay, it might be different. For example, like this. I have f of x equal to square root of x minus 1. Now, in order to find domain of this one, we're gonna set the radical x minus 1 greater than or equal to 0. Why we have to do that? Because the radical must be greater than or equal to 0. Because if it is less than 0, we cannot take square root, right? So we set it greater than 0. When we for x and x greater than 1, so the domain will be from 1 to infinity. So you see that it's different from this. You see, the sketch of this one we had the same shape, but the domain is different. Okay, now same thing for this. Now for function is n is equal to 3, which is odd, the domain is always like that. For the even, again you gotta set it greater than or equal to 0. Okay, alright. However, for the function g of x, if the radical is under the denominator, you're gonna set the radical greater than 0 only instead of equal to 0. Why? Because you cannot put 0 on the denominator. If it's 0 on the denominator, you cannot define it. Okay, so the domain is equal from 1 to infinity in this case, and no included 1, because if it is 1 over here, so 1 minus 1 is 0, square root of 0 is 0. You see that you cannot divide it. Excuse me. So excuse me. So on the third remark, I'm going to put if even radical is under denominator, then you have to set radical greater than 0 only. Okay, and the final remark. Okay, final remark. I'm going to put over here remark number 4 is that for the remark number 4, for all odd radical function, domain is always go from negative infinity to positive. But you see that for the even radical, right? The domain could be different. Okay, could be different. Okay, the shape will be the same, but the domain is different. Alright, so this is a very quick and short lecture. Again, if you guys have any question, please let me know. Next time we're going to talk about how to convert radical expression to rational expression. So you will be introduced to a rational exponent, which is an exponent in fractional form. Okay, I'll see you next time. Bye bye.